we can discuss from the last lecture what we have discussed in the lecture. You have any question regarding that lecture that we have discussed in the board plot, can ask me, and no question, no problem. You should be ready with the semi-log paper that you have plotted the log magnitude curve. Keep it in front of you. We are going to start from that point of view. From that point onward, what we have started up to. Now, finished up to. Now, can you please tell me the equation that the board plot we have uh, completed so far? What was the GS value on the top? Is it 20 or what? Can you tell me the equation? S plus 1, S plus 2. Is it 20 or something else?
It was 2.
What was that value? Magnitude?
2.
2.
Yes.
Oh, not 20, only 2. Okay. So you have to delete the 20. Okay, this is the one,
Yes, sir.
right? Okay, just can you tell me what were the dB and degree? What was the omega value was 0.1, another one is 1, another one is your 2, another one is
Yes,
50,
sir.
right? And dB, what was the dB?
19.94 plus
19, oh sorry, 19.94, okay. 19.94,
minus
then
3.97
3.97, and
minus
then
16.02
16, and then minus
95.9
96. Okay, angle
minus
first one.
98.57
Okay, 98, and then next
minus
minus
161
61 degree, then
198 minus
then
266.
66 degree. Okay, now based on this value, we have plotted the thing, and in the plot on the semi-log graph paper, if you go on the semi-log paper on the last
Sir,
got the
can I
what we have started with in the last class. All of you please take the semi-log graph paper. Today we are going to draw the phase angle curve, as we haven't completed the phase angle curve yet. So the magnitude curve we have drawn in the last class based on the, actually I'm just going to go for it again in short that you can just compare it also. This is 0 dB line, 0 dB line. This is one of the point, and this is 20 dB. This is minus 20, minus 40, minus 60, minus 80, and minus 100 dB. And this is one of the point we got, and another one was 1. So one is this and another one was 1. So one is there, 1, and another one is 1, and that one will be like this. And okay, this is omega equal to 1, 0.1. This is omega equal to 1, and then 2 is here, omega equal to 2. Okay, and 2, then omega equal to 50. 50 means so 500 we gone. So this is your 500. We can just check your answer you got. This is 50 radian per second. So, and this is 0 dB. So this 1 point, another point we got for 1, we got minus 4. So minus 4 is somewhere here, minus 4. So that we got the minus 4 point here. And then we're going to 2, minus 16. Minus 16 is somewhere here. So we got the point somewhere here. Okay, and then another one is minus 96. 96 is here somewhere here. So 96 we can get from here. And then we have drawn the curve like this, actually a symptotic curve we have drawn, then another segment we have drawn, and then another segment we have drawn straight away. And these are the three segments we got, and this is 20 dB per decade, minus 20 dB per decade. This is our uh, minus 40 dB per decade, and this is your minus 60 dB per decade. This way we have seen in the last class the log magnitude curve, and today we are going to see the phase angle curve. And the phase angle curve, if you go, you can see from here the phase angle equation, minus 90 to 270. The maximum is 270 minus 270 degree, because omega infinity, and 0 gives you 90 degree, and minus 90, and this gives you 270 degree for infinity. The infinity gives you 270 and 0 gives you minus 90. So 90 to 270, in between the segment should be given. So if you go for 90 to 270, this gives us 90, you can start from here, this is 180, and then you can go for 270. So you can take these things as a minus 90 degree. This one, same line, which is minus 100, should be fine. And this is minus 180 degree, and this is minus 270 degree line. If you consider that way, then minus 0 dB line is a base like that. Here the base will be here 180 degree. So you can just draw the baseline 180 degree line as the baseline. Okay, so 180 degree baseline if you draw, then 90 is there. So where is the point? If now you can consider uh, minus 98, 0.1 gives you minus 98. So if you can plot minus 98 here, uh, I have started today's class actually, that both plot 2 we are going to go, that means phase angle curve we are going to draw. So minus 90 degree, 98 is somewhere here, so you can just approximate. This is not a hard and fast, just 98 is somewhere here, you can draw the point. Then next point is coming here as a minus 161, approximately 160. So minus 90, this line will be what? Minus another 45. If you 45, 125 degrees, isn't it? 90, 35. 135 degree. 90 plus 45, 135. Then it is 180. Another 45, then you get the 80. And this got will be what? Minus 225, 225, which is another 45. These are the line segment you can get. So 161 will be somewhere here, and that is somewhere here. You can go 161 approximately. It's not necessarily 100% accurate. And then your 100, 200, 198 means almost 200. So 200 is somewhere here, or 198, and that can be here somewhere. So you can just put approximately 200 is somewhere here. And the last one is 266. 266 means 67. So 270, 60 will be somewhere here. So you can approximately draw this line point here, approximately. After getting these 4 points, okay, you have, I think, seen the thing, 4 point. Okay, I'm just going to pull it up. Okay, can you see the screen? Yep, all the 4 points you can see, right? Now, all what you have to do, what's wrong? Any question can ask me, otherwise I'm just jumping. Okay, once you drawn the 4 points approximately, the phase angle point, then this time please, you do not use the scale. Last time the phase angle curve, for the log magnitude curve, when you have drawn, you use the what do you use? Scale and your straight line you have drawn. But phase angle curve is not like that. Phase angle curve, you have to draw the freehand drawing. So freehand drawing means after getting these 4 points, then and next point will be going to the infinity. Infinity means 0. Okay, because of 90 is 270. So from 98, you can draw the freehand drawing like this, approximately freehand drawing like this. Okay, after getting like this and then jumping down and jumping down like that, like that, to throw that to 0 like this. Just a freehand drawing you have to draw, no need scale or anything for this case. So this is your phase angle curve. Okay, that's a phase angle curve done. A log magnitude curve and phase angle curve is completed. Okay, after drawing the phase angle curve, now it is the complete Bode plot. You have completed the Bode plot. What to do next? Next, we have to do the analysis of each of the parameters for the Bode plot, and what are the parameter we are going to analyze. Let us go through that. The thing what we are going to see first is the two things we are going to go. Was a Bode plot gives us, we have to find two things from here. One is your GM, one is your PM. GM stands for gain margin and PM stands for phase margin. Okay, so to get the gain margin, what is the definition? The gain margin definition is, we have to, for the gain margin, we need to get the omega P, and for need to get the phase margin, we need the omega G. Omega P and omega G are the, what do you call that, phase crossover frequency and phase crossover, gain crossover frequency. So gain margin to find, we need the phase crossover point. So to find the gain margin, we need to find the phase crossover point first, and then we have to find the frequency, and then we'll get the gain margin. So the phase crossover frequency, what is that? The phase crossover point, phase crossover point, we have to find first. The phase crossover point will give you the phase crossover frequency, and that will give you the gain margin ultimately. So the phase crossover point is the point of, the point of intersection between phase angle curve and minus 180 degree, and the frequency at that point is known as phase crossover frequency. Which is defined as omega P. This is your omega P. Okay, so first you have to find the omega, the point. First you find the crossover point. Once a gap point, at that point, what is the frequency? That will be the phase crossover frequency. Now let's go for finding that point. If you go to the graph paper, look at it first. It is the point of intersection between two things. Point of intersection between the phase angle curve and minus 180 degree line. Just right here, 180 degree line. This one is a 180 degree line. Okay, if these two things intersection will be there. So if you go there, now what is the phase angle curve and intersection point? This is the blue curve, is the this is your phase angle curve. This is the phase angle curve, and minus 180 degree is this line, minus 180 degree is this line, and they are intersecting where? They are intersecting at this point. This is the point of intersection. So at this point, with the scale, you can draw the line, and that line is the frequency intersecting the frequency. That is the frequency line you are getting through that intersection point, and that point giving you the frequency here at okay, somewhere a little bit to the left. Okay, here we go. So somewhere here, which is your omega c, omega p. Okay, this is omega p. Okay, this is your omega p, phase crossover point, phase crossover frequency. So this phase crossover frequency, in my case, I can see here, it is 1.25. So I got the phase crossover frequency is 1.25 radian per second. For me, it is 1.25 radian per second. Hey, you understand?
Yes, sir.
Okay, now all of you find your omega p and tell me, anybody got your omega p, can tell me what anybody got. Anybody can tell me. Sir,
1.2.
1 point?
2.
Okay, good, 1.2. Adnan Islam, can you tell me what is your value?
Sir, 1.4.
1.4, very close. You say, okay, close to 1.2, fine. Patwari?
Yes, sir. I have also got the 1.26.
Remember, maybe I can ask you to show me. So
Yes,
if
sir.
you
No
haven't
problem.
done, anybody, please let me know. So I could not do it or something. This is okay, no problem. But tell me carefully, because I may ask you. Saud Naman, what is your value? Saud Naman didn't do it. Okay. Can tell me, Saud Naman, what is your value? Okay. Yeah, what is your value? 1 point?
1.20.
1 point? 20. Aditya Das, did you do?
Yes, sir. My
What is
value
it?
is
1 point what?
1.2.
1.2. Didar. Didar, have you done?
Yes.
What is your
Yeah,
value?
no, sir.
What is your value?
No, sir.
Oh, you didn't do yet. Okay, do it and have to follow me. Otherwise, you'll be in trouble later. Okay, good. I think some of you have not complete yet. You have to follow me. Otherwise, meaningless to come to the class. And without class, also you cannot learn. So, Jannat, Rahtul Jannat, did you do?
1.2.
1.2. I assume everybody doing this. If you do it, you will be benefited. Otherwise, you cannot answer in the exam. And it has happened. And not only exam, you need to learn it. Atikur Rahman, have you done it?
Sir, I have told 1.2.
Oh, I'm sorry, you already told me. Okay, good. Next, I think most of you have done. Pranti, Maimuna Pranti, have you done?
Yes, sir.
What is your value?
Yes, sir. 1.25.
Excellent, good. Now, everybody, I hope that you all got it and you have done it. Now, look at it. What you have to do next? Next is our to determine the target, which is a gain margin. Now, from here, next is we are going to find what is the gain margin for this case. That one we have to find from the curve. Let's go to the curve and see here this line intersecting the 0 dB line at certain point and 0 dB line at this point, and it is intersecting the log magnitude curve at this point. These are the 2 points we have to identify. Now, if you see the 2 points which is intersecting the log magnitude curve, let's say the log magnitude curve intersection point, I can name it as A, and 0 dB intersection point, if I say the name is B, then the gain margin will be the difference between these 2 points here. Gain margin will be equal to B minus A. Formula is B minus A, provided B is the intersection of the 0 dB line intersection. The 0 dB line intersection point minus the log magnitude curve intersection. That is the formula. So if you find a B minus A, let's say our A is something like, in our case, in my case I'm talking about, it is coming here, coming here, coming here, like this, which is, let's say, 6 minus 6 dB. In my case, it is minus 6 dB. How? Okay, you can see the intersection 6 dB. So it is 0 minus minus 6. 0 minus minus 6 means it is plus 6 dB. Plus 6 dB. So the gain margin is B minus A. This gives you 0 minus minus 6, which is plus 6 dB. So the gain is positive 6 dB we are getting. Now, all of you go ahead and find your own gain margin, and I'll ask you a question, you give me the answer. Okay, Rokon Ujjaman, Rokon, did you do? Hey, Rokon, are you in or busy with something? Yep.
Yeah, I mean,
Okay, what is your value? Did you calculate?
so I didn't calculate yet. I'm
Okay, you
doing
do it faster. Anyone else had done?
I
Anybody?
have
Sir,
done
4
my
dB.
4 dB, you got 4 dB, positive 4 dB. Okay, then
Yes, sir.
what is the other guy? So
sir. I have done, but my ones is almost 10 dB, sir.
10 dB, who? Adnan,
11
Patwari,
percent.
Patwari. Patwari got
Sir,
10
I
dB.
also get 10 dB, sir. Adnan.
Adnan also got 10 dB. Patwari and Adnan, what is your omega G, omega P? Adnan?
So my one is 1.2, sir. 11
Sir,
percent.
my omega P is 1.35.
Okay, whatever. If it is 10 dB you got, it is okay also. But all positive 10 dB or negative 10 dB.
Positive 10 dB,
Ah,
sir.
that's right. So you got positive
Positive
10 dB
10.
close to 6 dB. It's okay. Positive 10, positive 6, all are very close. Another guy got positive 4. Any other people can tell me the answer?
7,
Positive 5.
Positive 5. Good. And then
7,
Didar, did you do? Didar, you did not do last time. Could you complete yet? Didar?
Sir, 4, positive 4.
Positive 4 you got. Okay, fine. I think most of you have done. And assume, I'm assuming positive 6, and you can assume your one. Whoever got who's what value, you can just keep it with you. That's all about the gain margin, how to find this gain margin parameter from the dot plot. And the next one is the phase margin. As I told you, the phase margin thing we have to find the other way around. It should come from the omega, as I say here, it should come from the omega G. Omega G is the gain crossover frequency. So gain crossover frequency will come from the gain crossover point. And what is the gain crossover point? The writing here, the gain crossover point, gain crossover point is the point of intersection between the log magnitude curve and 0 dB line. Very simple. And the frequency at that point is called the gain crossover frequency. Frequency which is represented by omega G. That's your gain crossover frequency you can find. But it is the intersection between what? It is the intersection between 0 dB line and the log magnitude curve. So this log magnitude curve and 0 dB line intersection point you have to find first, and then corresponding frequency exactly the same way what we have done. And let's go and do it. Now we have to go for log magnitude curve and 0 dB phase angle intersection point. So where is the point? If you want to find it, then you can see that the point is coming here. This is the log magnitude curve. This is the log magnitude curve Okay, going like this, intersecting the 0 dB line somewhere here. Maybe you should get different value, doesn't matter, but I am getting here the intersection point is somewhere here. Somewhere here. Your case may be different. So this is the point where the intersection between log magnitude curve and 0 dB line. So we have to draw the frequency line along with this point. So this point, the frequency line we are going to draw, that frequency is your omega g, the gain crossover omega g. So in this case, the omega g for my case will be 0.8, something approximately 0.8. Now maybe your case is something different. Okay, 0.8. So my case is 0.8. Omega g is 0.8. Okay. 0.8 radian per second. This is my omega g, 0.8 second. You can find your one. What is your value? Any one of you got similar type of value? Tell me, what is that?
Sir, I have
I
got
got 0.7.
0.7. Good. Then any other?
sir, I have got 0.52 radian per second.
Who are you? Patwari.
Alamin Patwari.
Okay, 0.56. Okay, good. That's okay. Should not get
0.7.
0.7. Should not get more than 1, I hope. And should, yeah, that should be fine. It's a less than 1, any value you are getting, all are correct. So I think all of you understand it. Now let's come back to the next point. This line intersecting, what to do, phase margin we are going to find. This line intersecting the phase angle curve, look at it, and the minus 180 degree at this 2 point. I'm drawing the point. You can see the point, the red point I'm drawing, one here and another one here. That means this omega g is intersecting the phase angle curve at point, let's say this is, I can say C, and another point, it is intersecting the 180 degree, minus 180 degree at point D. So C and D, these 2 points now you have to draw. And likewise, that one, you have to find the phase margin from here, the difference between these 2 points. This is your phase margin PM. Now PM is coming here as equal to C minus, the formula is the intersection point, log phase angle intersection point minus 180 degree intersection point. This is opposite. So C minus D. C is, for my case, I can assume that C is like this point, if you can consider, and this point is coming here, for my case, is something approximately this value. If I say, yeah, 135, and this is 180. Let's say it is approximately around minus 150. If I write 150 degree, so in my case it is 150. So C minus D means minus 150 minus 180. D is minus 180. So 50 minus 180 degree is means minus 150 plus 180 means we are getting here, I'm getting here plus 30 degree. So my phase margin is positive 30 degree. So now my question to you, what is your phase margin? Anyone can answer.
The 25.
25
So
plus or minus?
25.
Plus or minus?
The
So
plus.
plus.
Plus 25. Yes, 25 makes sense. It is okay. Now, any other guard? I'm just Mahabub Shifat. Are you working or just sleeping? Mahabub. Hey, Mahabub Shifat. Mahmoud Sifat is not here maybe. Are you here, Mahmoud?
Sir, I'm working, sir.
Yeah, go ahead. What is your value? The phase margin. Oh, you're working.
Yes, sir.
Oh, you haven't completed yet.
Sir,
It is not good, Mahbub. I think you should follow me. Otherwise, you'll be in trouble.
sir,
Yeah. What
I
is your
got 40.5.
good? It is acceptable, definitely. But positive or negative? Okay. It should be
Positive,
positive,
sir.
right? Saida Amanna Sadia. Sadia, what is your answer? Did you do?
Yes, sir.
What's your answer?
45.
35. Good. 35 you got. This is quite good. Now the last
Sir,
person,
I have got sir nearly sir 40.
you got 40
40
is
degree,
okay.
positive
Positive,
40.
positive 40 should be fine. The last question I'm asking, then we're jumping to the next Razak. Tawfiqul Islam, have you done or you are sleeping? Tawfiq,
Sir, I've done, sir. My one is positive 36 degree.
good, excellent. So I think all of you have done it, and I'm noting down. Now look at it. The phase margin now, you get it 30. For me, actually, I'm just telling you, the phase margin I have got here is phase margin. We have got here what I got 30 degree, isn't? I got 30 degree. C minus D is minus 150 minus 180 degree, and that gives you a positive 30 degree. Now we got conclusion is the gain margin I got 6 dB, positive 6 dB and 30 degree. So the gain margin got positive 6 dB, and phase margin I got positive 30 degree. So if the gain margin and phase margin both are positive, gain margin and phase margin both are positive, the system is stable. That is what you always can see. That means if you go with the shaded area under the curve, for example, shaded area under the curve is this one, this one, this one, this one. This is the, and if you go for shaded area under the phase margin curve, then the shaded area under the is this one, this one, this one. So this is the area under the curve. Okay, this is the area under the curve is the phase margin area, and that is the curve under the curve is the gain margin area. You can see the gain margin area curve is something like this here. So we can see the gain margin. I'm just taking it off so that it can be clearly visible. Okay, I hope that you get it now. Okay, and this is the gain margin area, phase margin area. Both are positive, positive. You are getting system is stable. Now we can just draw it here, and you can see it's something like this. If you can just go ahead like this. Okay, so gain margin if it is like this, like that, and the phase margin curve is going like that. Like that. Okay, like this, like that. Then this is our case I'm just talking about, and then this is the intersection point. So this is the another intersection point, which is connecting here like this. So the gain margin, phase margin is coming here like this. This is the area for the gain margin. This is the area for the phase margin. That's what I'm talking about. And this is your gain margin. In our case, for example, a 6 dB, and this is phase margin for our case is a 40 dB plus 30 dB. For my case, I'm just 30 dB. 30 degree. So this is a stable system, we can say. But if you change your gain in the, look at the equation. In the equation, you can see the gain if you put it as a gain K. k equal to 2 here. I'm writing here k equal to 2. That's what we got. Like if you get it like that, then k divided by omega root over 1 plus omega square 4 plus omega square, and the phase angle, you know that, minus 90 tan inverse minus tan inverse omega by 2. This is what you know. Now you are going to get 20 log of this is the dB. dB means you are getting like the 20 log of the whole thing. You bring it here. This is the magnitude and this is a phase angle. Okay, where is the k? Hey, listen, k means the gain. The gain is affecting what? The dB or degree or both? If you change the gain k value,
dB.
The dB.
it is only changing the dB value. Phase angle has no k inside, so k has no influence on the phase angle. So phase angle curve is fixed. Whatever value of k you put doesn't matter. Your phase angle curve, PA curve, is fixed. Only the log magnitude curve can change. So k value, you can, in our case it is 2. Now if you go for k value equal to 10, 100, 200, 300, a different value, then it will be affecting the dB. dB means it will be affecting the log magnitude curve, not the phase angle curve. So the log magnitude curve will be changing here. Log magnitude curve can go up or down. Means it can go, let's say if k value is increasing, then the maybe log magnitude curve will down, and if it is decreasing the other way around, then the log magnitude curve can be changed to different value, like it can increase the value like this. Okay, just some more value, I'm just going to do a bigger value or some bigger value, whatever. Okay, it can go up or down, the log magnitude curve, if you change the k value. So I'm going to take it off to not to make cloudy here. So you understand, if the k value is changed, it will change the log magnitude curve, not the phase angle curve. So if that is the case, then what can we say here? If the k value is changed, then the log magnitude curve, phase angle curve is fixed. Let's say it is fixed here. Now if the log magnitude curve is gone up or down, so the log magnitude curve can go like this, go like this, go like this. So these are the 3 points. Can maybe, I'm just talking about it's in change is shifted up. That means because of the k value change, the shift the log magnitude curve shifted up. It is LM, and this is PA. So PA curve is same. PA curve I'm just giving is same, but the log magnitude curve is changing, so the curve gone up. Let's say if this is the scenario, in that case, what happened? This is the you know, the log magnitude phase angle crossover frequency point, omega g and omega p is changing. Last time this was omega p, and this is omega g, and this time it is omega g, this is omega p, right? According to definition, it is the thing happened. And what happened now? If you go, then you can see the phase angle curve or phase margin is coming now like this, gain margin, and phase margin is coming like that. Now if you find the phase margin, gain margin, the gain margin will be what? Because this is positive point, and this is negative point. So a minus b, b minus a will be, negative or positive. What is the gain margin in this case? Negative or positive? Got my point?
Sir, it should be, sir, negative. Sir.
Negative, because this is B, this is A. So if you say B minus A, also same here, 0 dB line, this is 0 dB line. So 0 dB line is a B and A point is this one. This time A is positive value, so it will be negative. B minus A will be negative. So this time, this is gain margin is positive, and gain margin here is negative. And in this case, what happened here, if you go for CD point, again, if you go for CD point, C and D, and that will be different because C and D, this is your 180 degree line, 180 degree line. So your C minus D will be same. This is C and this is D. So over there, the formula is your D minus C. Here also D minus C. So in this case, if it is D minus C formula, same formula used, in this case, the phase margin will be what? Positive or negative?
Negative, sir. This is also
Negative.
negative.
It will be also negative. So this is the scenario. If the gain margin is negative, phase margin is negative. Okay. So this is what I see. The gain margin is positive, phase margin is positive. So its gain margin is positive and phase margin is positive. Then system is stable. And if you see gain margin is negative and phase margin is negative, the system will be unstable. This is what you can get it from here. Now, if you look at this, if we shift the, okay, here one thing you can say, omega p is greater than omega g, right? You can understand it. Omega p is greater than omega g. But in this case, here, omega p is greater than, I'm sorry, omega g is greater than omega p. Opposite thing here. And another case I'm going to say that if we go for this case, this is 0 dB and this is minus 180 degree, and your gauge margin phase angle curve is same. So you are going to draw the phase angle curve like this. And what about your gain margin point? Is a gain margin is coming here. So the phase curve and the log magnitude curve, if you change your log magnitude curve here, is it, oh, sorry. Let's say this is gone like this, and then this is gone like this, then this is gone like that. It's shifted down. So this is one corner frequency point, this is one corner frequency point. So if this is your log magnitude curve, LM curve, okay, and this is your phase angle curve. Phase angle curve is same, phase angle curve. Then what happened here, this is a case and a special case you can find where the gain crossover frequency, phase crossover frequency, or gain crossover point and phase crossover point are giving the same frequency. That means if you go with that, there's the same frequency you are getting, the same point, same frequency, so that it is giving you the omega g, which is nothing but omega p, same. So because the intersection between log magnitude curve and 0 dB, intersection between 180 degree line and phase angle are giving the same omega. So at the same omega they are, so in that case omega and omega p are same. In that case, if I say here, what is the gain margin? Hey, can anybody tell me what is the gain margin here?
That's 0.
0, because
0.
yes sir, because A and B are the same point. Here also same, C and D are the same point. So A minus B means 0, A minus B means here 0, difference is nothing because A and B same point. Here also phase margin is C minus D, which is also 0. So 0 degree, 0 dB. So one condition occurred where you get 0 dB, 0 dB. That means the gain margin is 0 dB, 0 positive, 0 dB, and phase margin is 0 degree. That is one special case. Hey, what is that stability condition?
Marginally
So
unstable.
marginally stable.
You understand, marginal stable, critically stable case is like that. So this is what we can conclude. And in this case, we can see that omega p is greater than omega g. In this case, you have found that omega g is greater than omega p. And in this case, what happened? Omega g, omega p. What is this? Which one is greater?
So it is equal, sir.
It will be equal. So this is a special case where you get equal, and other than that you get those case. So I think everybody understood the condition now, the gain margin, phase margin condition, and it can, same system can give you the gain margin, phase margin as a positive. That means for that particular value of k, this can be giving you positive, and for the different k, it can be give you negative. Then the system will become unstable. And if it is a particular k value, that gives you the system marginally unstable. So the question here, we got the K value. Hey, what is the K value in this case? So that we got 6 dB, I got 6 dB and 30 degree. What is the K value for this case? Hey, Dax.
2.
2, good.
2.
2, sir.
2, all our case is a 2 we got. And that is, the system is, our case here is a stable system. We got it. Now, for this case, the K value need to be changed. So can anybody tell me what could be any value of, let's say 3, 4, 5, what value can we put here? So that, guys, I'm asking your idea. What could be a value of K here, so that we can get the negative gain margin, negative phase margin, system will be unstable. Can anybody tell me what could be the value of K here?
Maybe 1.
Maybe 1. Very good. Do you all agree with him? If it is 1, then a system will be giving you negative gain margin, negative phase margin, means unstable. Do you agree with him? Hey, Dux, our problem is GH equal to, our problem, I said 2. 2 divided by S into S plus 2. This is our problem, right? S plus 2. For that, I got this one, which is stable, because positive 6 dB I got, positive 30 degree. You also got similar. And it is stable, because the K value is, here we consider 2 in our problem. And this one, we are getting negative gain margin, negative phase margin, means it is unstable. Definitely it is unstable. As I said, if it is unstable, then what could be the K value? So that our GS equation,
Yes.
yeah, GS equation will be what?
7.
What?
7.
One of your friends said 1,
Okay, should be 7.
not 1, right? Because
Or
1,
sir,
Not
3,
1, sir. Sir,
why you say 7? Hey, who said 7? Sumaya, Sua, or what?
yes, sir.
What's your name? Come on.
Sir, Sumaya, sir.
Sumaya. Okay. Sumaya, you told 7 because you saw in the dream.
No, sir. We did a math similar to this where we found the value of K for instability. It was more than 6. That's why I
Purity.
said 7.
Purity. Now I am asking, how come you say K equal to 1? I think Patwari told 1, right? Now,
Yes, sir.
yeah, how come you say 1? It cannot be 1 because you already got this equation. As you remember, you did in the Woothian array, you did everywhere this problem. That's why I take the same problem so that you can all understand very well. S1 plus S2, K value, K equal to 6, K is more than 6, less than 6, equal. Hey, remember, Patwari?
Yes, sir.
Okay, in the Ruthian array, Nyquist, everywhere you saw that. So K is more than 6, less than 6 is giving you the stable, unstable, marginal, unstable. K is less than, more than 6 is giving you unstable. Cannot be 1. 1 will be stable. But I ask you the, oh, I'm sorry, you cannot see. Okay, can you see now? Look at it. This is the equation. K is less than 6, more than 6, equal to 6. So more than 6 unstable. Okay, cannot be 1 because if you want to make it unstable, it must be more than 6. That's what you know the flavor last time. And what Sumaya said, it is 7. 7 makes sense. Yes, it is unstable. Sumaya, last time you did Nyquist stability criterion. It was what? Stable or unstable?
The last time it was
Same example we have considered. What was the K value there? You did the Nyquist.
it was
Anybody,
sir, I
anybody
did
can
it.
tell. In the Nyquist, what K value we
It's
consider?
Unstable, sir.
100, sir.
100. If we consider 100, which is more than 6, so system gives you unstable.
It's stable.
Yeah,
Unstable.
unstable. So
Unstable, sir.
yeah, -1 is the inside. Remember, -1 is inside means n equal to 2, 2 pole on the right hand spline, system unstable. Wait, so why? Because the 100 is more than 6 or less than 6.
More than 6.
That's why it is unstable. So you told me the answer 7. 7 also unstable, like 100 unstable. So if you consider 7 or 100, whatever value, you will get the negative gain margin, negative phase margin. That means system will be unstable. Patwari. Hello, Patwari.
Yes, sir.
can you tell me what should be the value of K for this problem? If it is marginal, 0 dB gain margin, 0 dB phase margin, I get for what K value of this system? Can you tell me now, Patwari?
It should be say k equals to 2 if we consider the example. I
Why?
guess, and the stable one should be say less than 2.
No, not less than 2. Look at it. What is this I written here? Can you see, Patwari, this thing?
Yes, sir.
What is this thing? Can you remember we did for the Ruthian
Nyquist.
stability criteria, Nyquist, Ruthian, K value was what? Borderline K?
So about k equals to 6, sir.
Right. Where you get 2? Not 2. K equal to 6, less than 6, more than 6. Stable, unstable, or marginally unstable, right?
So
That
I
one?
was talking about the sir that our board,
Yeah, our board
plots are
plot. Our board plot is done for K equal to 2,
2. Yes, sir.
which is less than 6, right?
Yes, sir.
Condition is, this problem's condition is, if K is less than 6, system will be stable. We consider 2 means 2 is less than 6, right?
Yes, sir.
That's why we got positive gain margin, positive phase margin. We got a stable system. Got my point?
Yes, sir.
Okay. Now, if K is more than 6, system will be unstable. Okay, if we say more than 6, what value? Maybe we can say 7, or we can say 100. Then the system will be unstable. Then the gain margin, phase margin will be negative, negative. Got my point now, Patwari?
Yes, sir.
Okay, now my question is, for marginally unstable and critically stable, what should be the K value?
K equals to 6, sir.
Why you said 2?
I was
Get my
considering our value, sir.
Now our value is, we assume 2. That's why we got it is stable.
Stable, sir.
If we consider it is 6, then we'll get marginally unstable. Got my point?
Yes, sir.
2 is our assumption, but we assume the 2 and then we found it. But standard borderline is 6, because we have seen the same problem in Ruthian stability criterion. We have seen the same problem in Nyquist criterion. Can you remember, Patwari?
Yes, sir. I remember.
Yeah, right. That over there, everywhere we saw, if this is the transfer function, open loop transfer function, K by S into S plus 1, S plus 2, then K value 6, less than 6, more than 6. System will be stable, unstable, marginally unstable. I hope everybody understood clearly. If you understood, I'll jump to the next point. But I am asking, do any one of you have any question? Yes, sir. You all of you understand, if both positive gain margin, if gain margin, hey, listen, look at this diagram. I'm sorry. Okay, just a minute. Can you see this? Can you see this? What is this? Hey, guts. Can you see this? Okay. Okay, what we can see here, if just I'm writing again, if the gain margin and phase margin positive, system is stable. If gain margin, phase margin negative, both are negative, it's unstable. Gain margin both are 0, 0, it is marginally unstable or critical stable. This is the conclusion. Do you have any question? Come on.
No, sir.
No, sir, no question. No, none of you.
Sir,
Yes, tell me.
Sir,
I know that one question must come.
can the scenario be that one is positive and another one is negative?
Who is the guy? Ask me this question. Name, please.
Sir, Khandakar Tawfiqul Islam.
Tawfiqul Islam. Good. This is every semester. At least one student must ask this question. And this semester, Tawfiqul asked this question. Good. At least that's why I'm asking you. What is the question? You should have. And this is the question. Tawfiqul Islam will be
Yes, sir.
declared to get $1 trillion if in your lifetime you can find one positive, one negative. You understand, Tawfiqul? What is the
Yes, sir.
challenge? You never ever in your life get like that, either both positive or both negative. So your answer is no. You'll come to know if you do the analysis, automatically you come to understand why you never get one positive, one negative. But a class performance test, all of you, okay, draw it and find the answer and give me the answer to the question. If you correctly can give me the answer, you'll get 1 bonus point. So all of you get ready and answer to the question. First, if you can do, the guy who can do it fast, raise your hand, and then I will give him the marks. Okay? Just be ready. I'm coming back. 1 second. Yes, all of you ready? Hey, are you ready or gone back home?
No, sir, we are ready,
Okay,
sir.
good. I think that's totally fine. Now I'm going to show you the screen, and immediately you have to take action. Find the answer from here. What will be the result? Okay, you find the, what you find is, you'll find the gain, remember, gain crossover point, phase crossover point, gain margin, phase margin, and stability. Good, go ahead. What is omega G, what is omega P, what is gain margin, what is phase margin, and stability. 3 questions you can see there. Gaze it, write it down on the paper and tell me. You don't need to show me by chat box, just tell me the answer. Create a snapshot and work out. Anybody done? Raise your hand and tell me. 2 minutes time.
Sir, I have done it. Hello.
Okay, come on. Who said I did it?
Sir, Atikur Rahman.
Atikur Rahman did
Sir, I
it.
also did it, sir.
Who is the next guy?
Sir, Adnan, sir.
I
Adnan.
also did
Okay.
it, sir.
Third person is who? Patwari.
Alamin Patel, sir.
Okay,
Yes, sir.
fine. Adnan second and Patwari third. Let's go with Atikur first. Now, Atikur, you tell me. Okay. Atikur, can you please in the chat box, you can send me what is your answer a bit faster. All of you, three of you, do it faster. Chat box, all of you write it to me. What is your omega G, omega X, and what is your gauge margin, phase margin, and stability? Faster. If you delayed, then I cannot accept it. Three of you cannot
Sir,
talk to each other. Send
we-
it to me chat box. That's right.
Sir,
Omega
should we
G.
send the photo?
No,
Or
no,
sir,
no, no.
write
Just
the value,
write
sir?
the value. Write the value and send me. All of you, three of you, write the value and send me. Good. This is Atikur Rahman. Send me. Hey, you are delaying other two guys. I'll not accept it. Okay. 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 Then can you send me? Yep. That's good. Patwari is sending omega p is 1.1, and Adnan send me omega.
Sir, I've also done it.
Yeah, Patwari send me 10. Okay, and then what is your stability? Adnan 0.1. Okay, 50. Patwari 50. Then 5 dB Adnan. Okay. Okay, then 60 degree. Okay, and 90 degree. Okay, okay, that's all right. I got the answer. All of your answer I got. Okay, I think what Patwari had done, all of you noted down. Patwari, can you tell? I'm sorry, not Patwari. Atikur Rahman, can you
Yes, sir.
tell the answer to everybody?
Sir, equals to 1.5.
Omega G is
Omega
1.5.
P-
Omega G is
Omega
what?
P equals to
Hey,
P-
come on. Omega G is what?
B crossover frequency.
1.5, right? And omega P is what? What is the value? Omega
Value is 15.
15 radian per second. And gain margin?
25 decibel.
25 dB. And the phase margin?
80 degree.
80 degree. System is?
Stable.
Stable. Okay, now let's come back to the point. And the rest of your value, I have checked it. Now, all of you can see the screen, right? Hey, can you see?
Yes, sir.
Yes, sir.
This is Atikur Rahman's result. Now, it looks, it is correct. And if we correct, then we don't need to go to other result. Omega P and omega G. So you can see the 180 degree line is there. So Atikur Rahman, if he got the 180 degree line here somewhere, and 0 dB line is there. So if the 0 dB intersection, he is going to go for that. The intersection 0 dB is coming here and intersecting here, and the 180 degree line is connecting here like this. Then his omega gain margin omega p p is this one, which is, he said that, okay, this is 10 to the power 0 means 1 radian per second. Remember, this is 0.1, and this is 10, this is 100. This is the way radian per second is. So this is 1.5, he said. This is 2. So 1.5 or 1.6, whatever. it makes sense. 1.5 is omega g. He said it is omega g, right? And omega p, he said 15, 10, and this is 10. This is what? 20. 20, he said this is almost 15. So it makes, okay, it makes sense. Radian per second, 15. Okay, then he got gain margin, phase margin. When you go for gain margin is this curve, under this curve. This is the gain margin, and from here to here. And he said this is approximately, what is that he said? 25. This is minus 25 dB. He is saying as a minus 25 dB. Because 50, half of that, actually he is considering half of it as the gain margin. So gain margin he get 25 dB. 0 minus 20 minus 25. Okay, he had written like this: 0 minus 25. It's a plus 25 dB he got. And then phase margin, omega cancel out. This is the 2 point he got. So this is the phase margin curve. So this is the C minus D, which is your phase margin. Phase margin is like he got, this is 100. What is that? 80. Is it 80? What is that? Come on, Atikur. What is this value you consider? 100. Okay, he got almost approximately 100 actually. So if he got 100, so minus 100, minus 100 minus 180 degree. So he is getting plus 80 degree. Okay, so at least you should consider a little bit less than 100, because it is not 100, it's a little bit less. So, oh no, it's 100 maybe. Yep, you're right. You are considering the 100 is correct. So plus, so it is giving you a positive 80, the positive 25. So his answer is correct. Positive 25, positive 80, omega g, and all are positive means stable. So he should get 10 out of 10, means 1 point, bonus point, he should get. This is Atikur Rahman. Atik, at the end of the class, you remind me for the bonus number. Should be fine? Atik. Now let's come back to the point. Everybody clear about it? All of you understand the problem? This is important. Anybody got any question? Hey, guts. What happened? Anybody got question? Can you hear me, all of you? Hey, can you hear me?
Sir.
Oh,
Yes,
anybody?
sir.
Yeah, you have any question? Anybody?
Yes, sir.
Well, where is the question? Tell me. If you have question, you can tell me. Patwari and the other fellow, you can check the answer now from your side, and then you can get the thing actually, because your answer all are positive, but a little bit big variation. So you can understand where is the mistake maybe. Patwari, you got the point?
Yes, sir.
Okay, good. And another fellow who sent me the answer, Adnan Islam, right? Adnan, you understand it?
Yes, sir. Now I understand.
Yeah, good, excellent. That's what I'm asking. Hey, rest of the guys, what happened? No participation, even you don't say anything, yes or no. Anybody need to clarify anything, or I can jump to the next one? Should I jump? Okay.
Sir, I have a question.
Yes, that's what I'm asking you. Ask me the
Sir,
question.
in exam, should we have to bring our... In exam, should we bring a botload, semi-log graph paper also?
No, semi-log graph paper, yeah, because this is online exam, so you have to bring it. Yeah, I'm sorry, because in the real exam, you should not, because we should supply it. But in the exam, yes, sir, you have to bring it, because you have to draw it and give me the scanning copy. Through the computer, I cannot send you the hard copy. You just get the hard copy ready for both the polar as well as the semi-log. I have already given you the soft copy, so you just get printed and be ready with that. I'll let you know these things before the exam. Oh, I'm sorry. If you think about the CT4 exam, of course, I'll let you know beforehand that you have to have a hard copy of it. I'm talking about the final exam. The final exam also, you have to do the same way actually. I'll let you know about these things, that you have to get the hard copy ready. But I'm asking you, you have to. So I think better, now I can tell you, all of you at least get ready with one polar graph paper and one semi-log graph paper. All of you, or both side, you can just print it and keep it ready with you in during the CT4, and during the final exam you can use this one. Okay, better 2 copy each, so that if you don't need it, then you can use the other one. Like that way you have to be ready. Hard copy I cannot provide you, so you have to get ready with that. Everybody please note it down. This is a very good question he asked actually. I never thought about it. Hey, all of you understand it?
Yes, sir.
Okay,
Yes,
don't
sir.
make
Yes, sir.
don't make trouble during the exam, sir. Where the hard copy I'll find. That's I think better. I'm just telling you. Of course, I'll announce it. No problem. Good question. Then any other question? Any other things? Otherwise, we are jumping to the next. I mean, this is the topic, but we have to go for. I'm asking you one thing to go. I think that next topic will be. Today I cannot do it because it is required some time. Determination of transfer function from log magnitude curve. This is one of the most important application of Bode plot. Note it down, determination of transfer function. That will be the next class. So we are going to do it. But before today, I have to go for one more problem. I'll just show you and then I'll finish it. Write it down, a determination of transfer function from log magnitude curve. Log magnitude curve. This is what need to show next class, and that's it. The end of Bode plot next class. After that, we'll go for root locus and query. Okay, that's all about the thing for that. What we can go, but now I'm going to give you a problem. Let's say in the exam, I will. Okay, now one thing before that, I'm just going to show you here. You can understand it. Look at it. The problem we have solved. Since you solved this problem and understood it, look. Okay, here. Now, if I ask you, carefully look at it. This is the log magnitude curve you have plot for k equal to what? Can you tell me?
100.
2.
K equal to 2. Good. Okay, so k equal to 2 gives you this plot. Now, we got the gain margin and phase margin. Both are positive, the positive 6 dB and positive 30 degree. Now, if I change the k value and make it 6, okay, I'm just asking you, if I want to obtain a marginally unstable or critically stable case, at the moment we are getting the positive 6 dB gain margin, positive 30 degree phase margin. System is stable. This is for the thing. System is stable because gain margin is below 0 dB line. You can look at it. I'm going to show you here one thing, then I think you can understand it better. Look at it. Okay, here. You can see here the gain margin, stable case, this is a stable case. Stable case, gain margin is under 0 dB line and above 180 degree line. And if unstable case, gain margin is above 0 dB line and phase margin is below 0 dB line. And only this case is on the 0 dB line on the area. That means we can conclude like this. Look at it. We can conclude like this. If it is 0 dB line and if it is minus 180 degree line, then if the system is stable, then the gain margin should go down, phase margin go up. So this is your stable condition within this region. So gain margin, under this is gain margin is positive and this is positive phase margin. But if the gain margin is the system is unstable, gain margin is negative, then the gain margin is above 0 dB and you are getting negative gain margin, and phase margin is below 0 dB, the phase margin is negative, it is below 0 dB. That means we can say that within this region 0 dB to 180 degree region inside is a stable system, and if the gain margin phase is above is unstable system, we can say. That is what we can conclude from here. But if you go okay, you can look at it here in this example. Just now you solved the problem. It is gain margin. Atikur Rahman got both positive gain margin, positive phase margin. What happened? It is gain margin is below 0 dB line, phase margin is above 0 dB line. So it is within the region like this. Gain margin and phase margin is within this region, isn't it? You can see gain margin and phase margin within this 0 dB and 180 degree line, in between this region. And if it is unstable, it should be outside the region. If you go here, you see it is within the region. Gain margin stable, phase margin, phase margin both are positive, means it is within this region. And if gain margin is negative and phase margin negative, it is above the 0 dB line and below the 190 degree, outside the region. It is outside the region. This is what I was talking about. Okay, fine. Let's come here. Now my question here, in this case, it is a gain margin positive, phase margin positive, system is stable for k equal to 2. Now, if I want to make it marginally unstable case or critically stable case, I have to shift the, which curve can be moved, which curve will be moving, the log magnitude curve or phase angle curve?
Log magnitude.
Log magnitude.
Yes, because the k value will be changing the log magnitude curve, and by changing the k value, we have to do it. Now, question is, what will be the k value to make it marginally unstable, or critically stable? That is the question. Now it is stable for k equal to 2. Now my question is, what will be the k value to make it marginally unstable? Now you said it can move, the log magnitude curve can move. Now which direction the log magnitude curve is supposed to move to get marginally unstable or critically stable? Up or down?
Upwards, sir.
Up, because our target is to make the gain margin equal to what? By shifting up.
Marginally stable.
Yeah, marginally unstable case means gain margin is what? Hey Duck, look at it.
0.
Look at it. Gain margin, marginally unstable and critically stable case, gain margin is what?
0.
So what are you talking? I'm talking about that thing. Always, for getting the marginally unstable case, marginally stable case, gain margin is 0. So here we have to shift the curve up, you said. How much up so that you can get 0 dB gain margin, right?
Yes, sir.
How much?
Decibel.
Maybe one what? 1 dB.
2 dB.
6
How many dB? In my, look at the screen and talk about my graph, not your graph.
6 dB.
Yes,
6.
6 dB. That is the answer. If you shift the curve, the red curve, the log magnitude curve, because we are getting the gain margin is 6 dB. Now, if you shift the curve vertically, it should be vertically up or down, because of it is just log magnitude curve, y-axis direction, dB value. So vertically, if you change the curve upward direction, if you shift it by 6 dB up, then the what? Then the gain margin will be what?
Marginally unstable.
I am asking you, what will be the value of gain margin?
0.
0.
Oh,
Zero.
0.
Yeah, if you shift it up 6 dB, the gain margin will become 0. Everybody need to understand it. I'm just going to show you here, then it will be clearly understood. I think you got it already, but I'm just telling. This is the curve. If you shift the gain margin 6 dB here, that means if I shift it up like this, if the curve goes like this, then The short curve is shifted up by 6 dB means this curve will going through this. A point and B point will be the same point. So this will be, A will shift it, A will be jumping up to this point. So A and B will be same. A and B difference will be 0. So if you shift it up by 6 dB, then you can get the gain margin, marginally unstable case. So that thing can be found like this. Shift it up means positive 6 dB, plus 6, up 6, down means negative. So 6 dB up, so 6 dB equal to 20 log of, dB means what? 20 log of K. So K prime you can just say. So what is the K prime value? Find it from here. Up means positive, positive up means positive. So 6, can you tell me what is the value? 10 into 20, do you know this calculation? 10 to the power, what is the answer? 10 to the power. Is this a way to calculate it? You I think you know that.
So it's 2, 1.99.
1.995.
995. 2.
995.
Approximately 2. Are all of you get it? Something like that. Okay, it is my thing, but for your own case, all of you can find the value. 6 will be what? You got what? Some of you got 5, some of you got 10, some of you got what? Different value, right?
Yes, sir.
Yeah, what is your value you got? Okay, those who got what? Anybody got close to 3? Just take
3.16.
what? Hey, what?
3.16.
3.16. This is more accurate value, because here we can find out whose answer is more correct. But I got 1.99 is absolutely not correct, close to correct value. 3, if anybody got close to 3, his value is very much correct, because this value, this K prime, okay, this K prime will be multiplied with 2, because 2 is the current value. 2, so K prime, the K will be, the final K will be this 2 into this K prime, and the K prime is 6. This will be the final value. 2 is already having, so you have to shift by 6 on top of that. That means 2 into that new K prime value will be here, which is giving you 6. If some say 2 into 3, that will be 6. So 3.1, the guy who got 3.1. Hey, Duck, who said 3.16? You told me liar.
Mahbub Sifat.
Yeah, then why don't you talk? Okay, Mahbub Sifat, what is your gain margin? You drawn and you got gain B minus A equal to
10
what?
dB.
Positive 10 dB. You are more accurate. So anybody got close to his value is correct. And 10 means 10 by 20, 10 to the power 10 by 20, 10 to the power 0.5. Is it 3?
3.16.
3.16. Those who got the value close to 3 or close to 10 dB gain margin, their graph is more accurate. This is the proof of it. Okay, now let's come back to the next point. This is what we are getting. Hey, do you understand why I multiply by 2?
Yes, sir.
Yes, sir. Good. Because the curve is already having 2 gain. K equal to 2, we got this thing. This curve we got already K value equal to 2. On top of that, we have shifted up another 6 dB. And that much will be multiplying with this gain actually. Like this. I'm just going to show you here, then you can understand. This thing is like this. Let's say this is the thing here. Then this is your K. And this is your the case here, like that. Or K you can put here 2. 2 is again, and then you are going to go for K equal to what? Divided by S into S plus 1, S plus 2. No, I'm sorry, this is not 2, this is 2. 2 you can put here, 2 you can put here, and this is the S plus 2, S plus 3. So this is your K prime. So I'm going to, 2 is there already fixed, and the K prime actually we are going to find on top of 2 to shift the curve up, and that new K prime value will be always multiplied by 2. Like that way actually you have to find the thing. So that is the reason why we are going to get, because 2 is the base value, as you understand it. It's very simple. Okay, now this is the way we can have the marginally unstable case value K equal to 6. I got answer is what? My answer is 4. 1.995 into 2 means almost approximately 4. Some of you get 5, some of you get 4.5, some of you get 7, some of you get 7.5, doesn't matter. Everybody get full marks. But Nadan, who got 10, he will be also getting full marks, but he is more accurate actually. That is the main thing. But all of you are correct. Don't worry about it. Now, this is one thing. Another thing I'm asking you, hey, all of you, can you follow me?
Yes, sir.
Good. Now, another thing I'm asking you, let's say I'm asking in this question, okay, can you please go for finding the value of K so that I can achieve 25 dB gain margin. Okay, for my case or for Nadan case, what you call that, Nahian's case, we got 6 dB. I got 6 dB gain margin. But my question is, try to get my point what I'm talking. I want 25 dB gain margin, 25 dB gain margin. I can tell you, hey, I want to get 25 dB gain margin. So what will be the total gain, final gain? At the moment, I got positive 6 dB gain margin, right? For K equal to 2. All of you got it?
Yes, sir.
Okay.
Yes, sir.
Let's say you get a job in my company. I ask you, this is the system. You find the stability, and you found the stability where K is 2. For K2, you got positive 6 dB, and you tell me, sir, the system is having positive 6 dB. I said, what gain? You tell me gain K equal to 2 gives me 6. I said, no, I want the gain margin should be 25 to make it more stable, because 25 dB is more stable. So go and do the experiment on this aircraft or helicopter so that it will be more stable. How much stable? I want more stable means plus 25 dB, not plus 6 dB. I'm not happy with that. As an engineer now, you have to go back, and what you have to do? You have to change the gain. So what will be the gain so that you can get 25 dB, not 6 dB? In order to do that, what to do? Yes, tell me.
I got K value 35.56.
How you did it?
So 10 to the power 25 divided by 20, then I multiplied it by 2.
Okay, who are you talking to me?
Matikur Rahman.
Who?
Matikur Rahman.
Atikur. Okay, what is your dB you got? Hello,
What?
in your problem for K equal to 2, what is the dB you got?
K equal to 7.
Okay, forget about that. I'm talking about mine one. I got 6 dB. In my case, I want to get 25. What to do?
I will use the equation 25 equals to 20 log K.
No,
times.
no. Absolutely
It
wrong.
should be minus 25 plus 6, then 20 log.
Why minus 25 plus 6? Okay, minus 25 plus 6 equal to what? Yeah, you are right. What is the value?
Sir, minus 19.
Minus
10 to the
19.
power minus
Okay.
19 divided by 20.
Absolutely. This is the answer. Because you're right now. Minus 19, you have to. Why minus? Because you shifted it down. Earlier you shifted 6 dB up, that's why it was plus. Now you are shifting it down, that's why negative. But how much down? You have to shift down by another 19. If you shift down by another 19, then 19 and 6 altogether it will be 25. So together you get 25 dB. I think this is the right answer now. It means, look at it, another 19 dB down here, another 19 dB down here, another 90, everybody 19 dB down. And then you draw the new curve. And what will be the new phase margin? New phase gain margin. New gain margin will be this 2 point. This 2 point means this 2 point here. This will be 25 dB. So from here to here, you shifted by 19, right? 19 and 6 is a 25. So you have to shift down by 19 dB, then 6 plus 19 altogether will be 25 dB. Atikur Rahman, you understand it?
Yes, sir. Now I got it.
Now you got it. Now shifted down by 19. Since you shifted down, that's why it will be minus 19. So what Patwari is a Patwari told me, I don't know what the people
Sir,
told
Adnan.
Adnan. What Adnan told me, the equation is minus 19. Look at it, minus 19 equal to 20 log of k prime. 20 log of k prime. So he got k prime equal to 10 to the power minus 19 by 20. What is that you got, Adnan? Adak, Adnan.
Sir, 0.1.
All of you got the answer, 0.1. Check, Adnan is not.
Yes, sir.
Okay, good. If this is the case, then k is that, so k prime will be multiplied with, 2. That means your 0.1 times 2 is giving you 0.2. So your k is, yeah, so the final k value is 0.2. It means if the GH you draw for 0.2 s into s plus 1 s plus 2, if you go for this, if you draw the Bode plot for this one, you will get the gain margin equal to what, Atikur Rahman?
25 decibel.
Absolutely good. Adnan could not get it even though. Adnan, you understood? No.
Yes, sir.
Okay, good. Thank you. So you should get plus 25 dB. Okay, I hope that everybody understood it, and we are going to finish it, but I'm just asking last question. If anybody can answer this question, he will get 1 bonus point. Now, everybody ready? Give me the answer straight away. In the final exam, if I give you the question that, okay, now like this way. If I give you the question like this, ask you k over s plus 1, s plus 2, s plus 3. Okay, now ask you draw, now using Bode plot, find the k value equal to what for achieving plus 50 dB gain margin. Okay, my question to you all, how will you start the answer? Within 1 minute you have to give me answer. 1 minute time. How are you going to start your problem? Understand the question.
I'll find the GH.
Find the GH. Okay, fine. You should get the GH equal to, okay, you, come on. GH equal to, what is that? K divided by s plus 1, s plus 2, s plus 3. Because H is 1, right? Hey, got. This is
Yes,
your
sir.
G, this is your H is 1. So you said you'll get find a GH. You got GH like this, right? It is your first answer. Then what do you do? This is not this, it's a given. How you start means what?
And
Hey, who is the talking to me? It's not clear. Huh? What is your name?
Atikur Rahman.
Atikur Rahman. Okay, I think you are not clear. Your microphone is having some problem. Okay, now tell me, Atikur, how you start? Your starting should be like what?
I'll find the LM equation from here.
Okay, LM equation and phase angle equation, you find it, and then you find 3 corner frequency, and then you draw the Bode plot. Is it?
Yes, sir.
Can you draw the LM log magnitude curve? Can you draw the log magnitude curve from the LM equation? Yes or no?
From the LM equation, I can find the dB, and
I know dB. How, okay, but can you calculate the dB?
I have to calculate the dB.
Yeah, for omega equal to 1, for omega equal to 1, omega equal to 2, omega equal to 3, 3 corner frequency, you calculate the dB for 3 corner frequency. If you go and calculate it from the log magnitude equation, can you, or you will be stuck somewhere? Okay, any other question? Atikur Rahman is over. Any other gut? Everybody is dumb. Atikur Rahman is on the right track, but you will be stuck. Do you all agree with him that you can calculate the points, log magnitude, dB points? Can you calculate the dB point for different corner frequency? 3 corner frequency you get, 1, 2, 3. But can you calculate the dB Tell me yes or no.
No, sir.
That's
There is-
right. What to do? That's the problem. That is the thing actually. Because our target is to find the K for 50 dB gain margin. Okay, none of you can find the, that means if this question I give you, even just I'm telling you, listen, even I give you this question, what you have solved just now, even I give you that question, you also cannot solve the problem, because if I give you the same problem, what you solved just now, and I give you the problem like this, what do you
Sir,
do?
we can assume.
If I give the same problem, what we solved just now, yeah, who is talking? We can assume. Already talk to your girlfriend.
Sir, me, sir.
Yes, sir. What's his name?
Because sir, in this equation there is a one thing we always do, like 20 log the k, 20 log k. So if we can assume it, then we can also change the value, and the other equations are in omega form, and then we can
I
make
got
it
it. Now
constant.
you Muqtadir, right? Muhammadul Muqtadir, right? Muqtadir.
Sir, Mahmudul Kabir.
I'm sorry, Mahmudul Kabir. You said we assume. What will you assume? The name.
Like 20 log k equals 50.
Why 60, 50?
Because gain is given that 50 decibel.
Yeah, but why you assume 20 log equal to 15? 50. Now, you have to assume to plot the log magnitude curve. What you have to assume? What you don't know? Where are you stuck? Anyone?
The value of k.
Right. This is the main thing. Already answer is given, so I cannot give you marks, but I'm just telling you. That is what Kabir, Muhammadul Kabir almost about to get the bonus point, but he missed it because he misguided me in different way. If he said, sir, we will assume the value of K and then we start calculating, then he should get 1 bonus point. Actually, that is the assumption you have to do, not other things. So what you assume, if you assume the K value, any value you can assume and do your calculation, and you see how much you have to shift the curve up or down. Maybe you can assume 2. If you assume 2, then you get, as I got 6 dB. So 50 dB means you have to shift it down by another 54 dB, right? I'm sorry, 44. 44 dB down means minus 44, 20 log of then K prime, you can find it from there. These two actually you can assume, or instead of 2, you can assume this value is equal to 1. If you always normally you do this type of practice, whenever K value is given, not given, you have to assume K value equal to 1. And then you can draw your log magnitude curve, phase angle curve, and find the gain margin. And then you see your gain margin, how much difference from 50 dB, and adjust that. And then you can find your required K value. You get my point?
Yes, sir.
Bahadur Kabir, good. So I told you the example that if you assume 1, you should get some dB. Maybe you get a plus 3 dB or plus 10 dB. You get 1, let's say 1, and you draw it and do the same way. I got 6 dB instead of 6, maybe you got plus 10 dB. You get 10 dB. Question, what is the question? Question said you have to find what? Positive 50 dB. But, oh, I'm sorry, you cannot see the thing. Okay, positive 50 dB you are asked. If you consider 1, then you get 10 dB, and your question is 50 dB. So what to do? Another 40 dB up or down?
Up.
Oh, you kill yourself. All of you agree with him?
No, sir. Down.
No, sir, down.
Because if not up, then it is down, right? You're thinking like that, is it?
Sir, negative.
Yes.
Points are
This is 10 dB. You got for K equal to 2. So you need 50 dB. So what happens? The curve should go down or up. You said up. Is it correct? If shift it up, then 10 will be 0 dB, and then it will be negative dB. But 50 dB is where? 50 dB is here. From here to here is 50 dB, right?
So down.
So now use a down, dumb. That's very simple, very critical issue. Okay, I hope that you understand it. In the exam, if the question come like that, you have to assume k equal to 1, and then you can carry on. So why? Because you shift down by, let's say, another 40 dB down, because it is a 40 dB, and this is 10 dB, altogether 50 dB. 40 dB down means minus 40 equal to 20 log k prime you write, and k prime, whatever value you got here, you simply multiply that by 1, and that will be your k, and that's the final answer. That's why it is better to consider k equal to 1. Straight away, whatever value k prime you get, that will be the answer. Sumaya, you understand it?
Yes, sir.
Yes, I hope that you should, because you understood the other one like this thing. So I hope that all of you understood that why I am asking you to assume k equal to 1. Let's say in our example, we assume k equal to 2. That's why whatever the k prime value, you multiply by 2. If it is 1, then you don't need to multiply anything. Whatever k prime, that will be the answer. Any children didn't born yet, understand it. Okay, now I hope that all of you understood what I mean, and you can easily answer to the question if it comes in the final exam. You clear?
Yes, sir.
Hey, rest of the people, okay? Because I'm finishing.
Yes, sir.
Yes, sir.
Good. If you
Yes,
are
sir.
clear, our board plot is over. Now, any question given from any final exam question paper, you can easily solve. And I will put some together in the BUX as a practice problem. All of you can easily solve those practice problems. Only one type of problem you cannot solve, that is transfer function determination from the log magnitude curve. That one, as I told you, next class, first hour, I will teach you, and after that we'll jump to the root locus. All of you please remind me, otherwise I will again forget and jumping to the root locus. I think that should be the end of log magnitude curve. After that we are going to jump to the new topic. Yeah, anybody,
Sir.
any question? Otherwise we're leaving the classroom. Yep.
Sir, you forgot to include my quiz 1 number in the Excel sheet.
Your bonus marks.
Not bonus marks, sir. I send you my quiz 1 script via the other email.
Oh,
You
I'm
have
sorry.
provided.
Yep. It is your city 2, right?
City 1, sir.
City 1 or
Yes, sir.
city 1 or city 2? What's your name?
City 1. Sir, Ashfaqur Rahman.
Okay, okay, I'm going to talk to you. Just stay back. Don't go. You stay back. And there is another guy who's supposed to get a bonus mark. Who is the guy? Today,
Atikur Rahman.
Roman. Atikur Roman, also stay back. You stay back. Any other people? No. Because officially the class is over. So you all can, those who want to go, you can go. You have class or something like that.